Hey there, how's it going everybody? In this video, we're going to be learning about the Pathlib module and how to use it. Now, this is used in place of the OS module for working with paths, and many people have been slow to move over to using this, but we're going to be learning about the advantages that it provides over using the OS module and why we should probably make that switch. Now, we do have a sponsor for this video, which is Extra Wallets, so I'd like to thank them for sponsoring the video, and we'll talk more about what they offer after this lesson. But for now, let's take a look at the Pathlib module and why it's now the preferred way to work with paths in Python. So Pathlib was introduced to the standard library in Python 3.4 and provides an easy way to work with file paths and the file system. So what's the big difference between Pathlib and the OS module? Well, the OS module, you're working with strings for paths, which can get a bit messy, especially when working between different operating systems. But with Pathlib, it represents file paths as objects rather than strings, and this will better handle those problems a bit more, and it's more intuitive, readable, and less prone to errors. And I'm not just bringing this up as a cool Python tip or trick. There are some large code bases out there that have switched over to using Pathlib. So for example, in the script that I have open here, I have two examples of a line from a Django project's settings file. The first one is from an older Django project where they were still using the OS module. And the second one down here is from a newer Django project where they've switched over to using Pathlib. And we can see the differences here. If we were to look at the first example using the OS module, it's kind of hard to tell what's going on. You have to break it down slowly and think, okay, so we're getting the absolute file path of this double underscore file, and then we're getting the directory of that absolute path, and then we're getting the directory of that directory. And it's a bit confusing when we try to break it down like that. But basically, all they're trying to do is set the base directory to the main project directory, which is 2 levels up from the settings file. Now, if we compare that to Pathlib down here, then all we are doing is resolving the absolute path of this file variable here, and then we're getting the parent of that, and then the parent of that. And if any of this is confusing, don't worry, we're going to go over all this in the video, but I just wanted to show you the differences in kind of how you break things down here. We can see that this OS one is a lot longer, and we kind of have to read this from right to left, where with Pathlib, this is a lot shorter. We're reading this from left to right, and it's just more intuitive as to what's going on. And we can see here that these comments with these Django files are different as well. We can see that to build the paths inside a project, that they want you to use os.path.join with this base directory in this older example. And in the newer example, they just have this base directory / subdirectory. And again, we're going to take a look at all this in the video. I just wanted to show you some real world examples right off the bat of some larger code bases that have made this switch. So now let's go ahead and jump into learning how to use Pathlib. So I'm going to go ahead and delete those examples that we have. And now you can see that all we're importing here is the OS module, and we're also importing path from Pathlib. So we'll walk through using Pathlib for some different things, and we'll also see examples of when to use Pathlib or when to use the OS module or another module if it has a better use case. So first of all, let's just look at the current directory that we are currently in. To do this, I'm just going to print out path, and that is CWD for current working directory. So I'm going to save that and run it, and then get my output open here. And we can see that we're currently in this tutorial directory on my desktop. Now, let's list the files and folders within this current tutorial directory. So if we use path without any arguments, then it will default to the current working directory, which is this right here, what we just printed out. So if we wanted to iterate over all of the files and folders in this current directory, then we could simply say for p in path, and I won't pass in any arguments, and by default that'll just be the current working directory. And we can use iter dir, and this will make an iterator of all the files and folders in that current directory. So I will just print all those out, go ahead and run that, and we can see that it shows us all the files and folders within our current working directory. So we have a file.txt, tutorial.py, which is the Python file that I'm running here, and then this directory 1. And we can also see these over here in the sidebar. So let me go ahead and take both this file 1 and this directory 1 and create specific path objects for each of those. So since they're in my current directory, I can simply say, I'll comment this out for now. I can just say my dir is equal to, and a new path object, and we will just pass in directory 1 here. And now I'll also do this for file. So I'll do file1.txt, and I will rename this variable to my file. So the way that I've done this so far is by using a relative path. Since I'm only typing in the directory name and the file name with nothing else, it's looking for those relative to my current working directory. Now we can also use absolute paths as well, and we'll take a look at that in just a bit. But for now, let's look at some of the information that we can get from these relative path objects. So first, let me print these out so we can see the output from both of these. If I just print both of these out, I will print out my directory, and I will also print out my file. And right now, if I save this and run it, then we can see that it gives the name of both of these. Now, if I wanted to be explicit, then I could go ahead and print out the name attribute for both of these. So I'll go ahead and do that. If I save that and run it, then we can see that we get the same thing here. We are getting the name for our directory and our name for our file. Now, another common thing that we might want to do is get the file extension. Now, if you're using the OS module, you might remember that to do this with that module, you would first need to split the file name and the extension and then grab the index of whichever one you'd like. But with Pathlib, this is just as easy as getting the suffix attribute. So I can say suffix, and I'll do that for both of these here. So if I save that and run it, then we can see that for our directory, we don't have an extension since that is a directory. And for our text file, we have this txt extension. And to get the file name without the extension, that is what's called the stem. So to do that, I'll go ahead and replace both of those with stem. If I save that and run it, then we can see that now we just get directory 1, and it didn't have an extension to begin with. And now for our file.txt, we're just getting file 1 without that txt extension. Okay, so now let's say that we wanted to access a file within this directory 1 here. Now these paths don't actually need to already exist when we create these path objects. So for example, directory 1 is currently empty. So let's create a path to a new text file within that directory. So with the OS module, the way that we would do this was with os.path.join. But with Pathlib, we have the ability to use this / operator that's common on a lot of file systems. So to do this, I'm just going to create this down here. I'll say new file is equal to, and now I'll use this existing path object of this directory, and then we have access to this / syntax here, and then I can just say, I'll just call this new file.txt. And now let's go ahead and print this out with the others. And I'm going to take off these stems here. So I will grab all of those, get rid of those, save that, and run it. And we can see there that our new file is at this path within directory 1. Now, if you're used to using the OS module and you're not comfortable jumping directly into using this / syntax here for your file paths, then you still have access to a method that does the same thing. So instead of using a slash, we can use join path as the method. So I can say my dir dot join path, and then we will just pass in that new file.txt. And if I save that and run it, then we should get the same thing here, and we can see that that worked. And like I was saying before, these don't actually need to exist in order to get this information. So this new file.txt doesn't currently exist on my file system, but we can treat that path just like any other. So if we wanted to see if these paths do exist, then we could simply use the exist method. So let me go ahead and do that. At the end of all of these here, I will add the exist method. I will save that and run it, and we can see that for our directory, we get true that it does exist. We get true for this file1.txt because it does exist, and this new file.txt, we can see that we get false because that file actually doesn't exist on our file system. Okay, so now let's maneuver over to looking more at absolute versus relative paths. And this is where I believe that Pathlib really shines over the OS module. So first of all, let's get an idea of where we currently are on the file system. So first, let's take a look at the parent directory of each of these paths. So to do this, I can just get the .parent attribute. So I will run .parent on each of these and print those out. So if I run this, we can see that for the first two paths, we just get this dot. And that means the current working directory is the parent of that path. For our new file within directory 1, we can see that directory 1 is the parent of that file path. And you can chain these together too. So if I wanted to go up 2 levels with this new file, then I could say new file.parent. If I save that and run it, then we can see that now it goes up to this current working directory level as well. And this is actually as far as these will go since these are relative paths. But maybe we wanted to know exactly where we are on the file system and have an absolute path to these locations. So in order to do that, we can get an absolute path. And there are 2 ways that we can do this. The first way is to use the absolute method, and this parent attribute is returning the path object also. So we can either use the absolute method on that parent object or on the original object. It just depends on how we would want to do this. So for example, what I mean by this is I could either say my directory.parent.absolute, and if I run that, then you can see that now we are getting the absolute path to this path location. Or I could just run absolute on that original pathlib object, mydir.absolute.parent. If I save that and run it, then you can see that we get the same thing. Now, if I just wanted to get the absolute path of this directory and not the parent, then I could just take that parent off there, rerun that. Now we can see that we get the absolute path to that directory. Now, another way that we can get the absolute path is to use the resolve method. And this is the one that I use basically 99% of the time. What this does is it gives you an absolute path, but it also resolves any symlinks or relative directory references. So for example, if I change this to resolve, so let me go ahead and do that, and I will save that and run it, and we shouldn't see any differences right now, and we don't. It just looks like the same absolute path. But if there were any symlinks or relative directory references in here, then we would see a difference. So for example, let me comment out what we have here, and let me create a new path to print out here. So I'll say p is equal to path, and I will make this path ... and then I will do .absolute at the end of that, and then let's just print out that absolute path. So if I save that and run it, then we can see we're getting this weird thing where it's taking us to the directory of our tutorial here, and then it has this ... directory, and that's not really what we want. So this ... here is a common relative directory reference that usually means the parent directory. But using this absolute method isn't resolving what we mean here by using that parent directory. So what we need to do is instead use resolve. So I'm going to change this absolute to resolve. I will save that and run it. And now we can see here that it knows that what we wanted here was our parent directory. And since we were already within this tutorial directory on my desktop, then it knows that the parent directory that I'm after is my desktop itself. So I found that for most of the time for what I need, I almost always want to resolve paths when getting their absolute path. And if we recall, this is basically what we saw in the beginning where we looked at how Django changed their code base to using Pathlib instead of the OS module. So what they were doing was using the _file variable, which is a special variable that contains the path to the current file. And then they were getting the absolute path to that file. And they were using the resolve method as well. So I could do that here by saying instead of ... I will use this file variable. And I don't want to put this within quotes because this is actually a special variable here. So if I save this and run it, then we can see that we are getting the absolute path to this specific Python script. So if you ever want to get the parent directory to a specific file like they were doing in those Django setting files, then hopefully now you understand this a little bit better of what they were doing. They were taking the current file, they were resolving that absolute path and getting that absolute path, and then they were just getting the parent of that absolute path. And in this instance, this is going to be the directory that contains my tutorial.py file that we are currently in. Now, in their example, their project directory was actually 2 levels up, so they put another parent there, but the concept is the exact same. Now, there are a couple more caveats about getting an absolute path that sometimes resolve won't take care of either. So for example, let's say that we wanted to get access to a user's home folder. So for example, I keep my .files and a lot of system settings in my .files folder of my home directory. So a lot of us may be used to using the tilde to access a user's home folder. So let me try that with a path. So I'm going to remove this parent for now. And now let's say that I wanted to make this path to my home folder, and I'll do a tilde/.files, and this is going to be used as my user's home folder here. Now, if I save this and I run it, then we can see that even with resolve, that doesn't work like we'd expect. It just added this on to the end of our current working directory. So instead, if we are parsing a string with the tilde, then you can use the expand user method to get the correct path. So instead of .resolve here, I will say .expand user. And if I save that and run it, then we can see that that works. It goes to users core EMS, which is my home folder, and then goes into this .files directory. And just like before, if we wanted to, then we could chain the resolve method onto the end of this if there were any symlinks or relative references in that path. Now, I'd only use this expand user method if I was parsing an already existing string. If I was creating this from scratch, then it's much better, in my opinion, to use the home method. So if I wanted a path to this .files directory, then instead I could just say path.home, and then we can use that / notation and just go straight to the .files directory there. If I save that and run it, then you can see that that gives us the same thing. So since I have this home directory here, let's say that we wanted to search this .files directory. So we saw earlier how we can use the iter_dir method to list all the files and folders in our path, but it's pretty limited in terms of searching. And also you need to do some extra work in order to get that information from within the subdirectories of our path. So in order to do some more advanced searching, we can use the glob method. So let's say that I wanted to search my .files path for any file or folder that has VS Code in the name. To do this, we can use some wildcards with the glob method. So really quick, let me clean up what we have here so far. Up here, you can see that is where we looped over that iter_dir method from before. but let me go ahead and clean this up, and I will actually just call this .files. And now let's search this using that glob method. So I can say for p in .files.glob. And again, let's say that we wanted to find any file or folder that has VS Code in the name. So what I can do here is I can use some wildcards and just put VS Code here in the middle. So it can be at the beginning, or it can be at the end, or it can be in the middle. That's what these wildcards here are. So anything at the beginning and anything at the end, as long as it contains this VS Code. So now let's just print out all of those paths that match that. So I will run that, and you can see that we only get one result here for this vscode.sh. Now there could actually be some more matches, but by default, glob only searches the path directory and not the subdirectories. So to search the subdirectories, we need to use recursive glob, which we can use just by adding an R before glob here, which stands for recursive glob. So, oh, actually, and I almost forgot, we're still not guaranteed to get all the results that we might be after here, because glob is also case sensitive, which is sometimes what we want, but in this case, I don't mind if there is a mixed case. I just want all of the results. So I'll add an argument here to this recursive glob, and I can say that I want case sensitive equal to false. So now, if I save that and run it, then you can see that now we are getting some more results here, and these have some mixed cases in them, and they are also within the subdirectories here. And you can use these wildcards in different ways. So if I wanted to instead find all of the JSON files, then I could just use a wildcard at the beginning and then say anything that has a .json extension. I'm not going to put a wildcard at the end, since we want anything that ends in a .json. So if I save that and run it, then we can see that now we get all of the JSON files in those .files. Now, let's say that we wanted to open one of these files in order to work with them. So we can do that just by passing in a Pathlib object into the open function, just like you might be used to doing with strings. So for example, if I wanted to open this VS settings.json file here, let me go ahead and just add this to my path. So I'm going to copy this settings VS code, and I will just add this on here at the end. And now, instead of searching over using glob, let's go ahead and open this up. Now, to open this file, we have a couple of different options here. The path objects actually have an open method of their own. So I could say with .files.open, and then I can say as f, and then let's just print f.read to get the contents of that file. And by default, that's going to open that in read mode. So I can just run this as is, and this is my VS Code settings.json file down here. So it did get the contents of that file. And if we wanted to use the more traditional method of opening files, then we can also just pass the Pathlib object into the open function instead. So instead of saying .files.open, I could say open and then pass in .files. So if I save that and run it, then you can see that we get the exact same thing here. Now, I'm not going to go in depth on how to read and write files in this video, because I have a separate video completely dedicated to that topic that I'll put a link to in the description section below. So if you're interested, then you can give that a watch. But the big thing to know here is that we can use these Pathlib objects with these open functions directly without needing to convert them to strings. So that's extremely useful. Okay, so now let's look at a couple more things that we can do with Pathlib, and also we'll see a few examples of where using Pathlib isn't the best approach and when using some other modules might be better. So with Pathlib, we have some limited ability to create, move, and delete files and folders. So let's take a look at some of these. So let's say that I wanted to create a new directory. So to do this, I'm just going to delete what we have so far, and I'm going to create a new path here, and let's just specify a directory that doesn't exist yet. I'll just call this temp directory. So in order to create this directory, I can use that path and then use the make dir method there. If I save that and run it, if we look over here in our sidebar, then we can see that it creates that new temp directory. Now, if this directory had already existed when I'd run that, then I would get an error. But there's an argument that I can add to this make dir method of, I think it's exists okay is equal to true. And if I was to specify that, then even if that directory already existed, then it would not throw an error. Okay, so now let's say that now that we have this directory that I wanted to remove it. So to remove this, I can just say rm-dir on that path. If I save that and run it, then we can see that now it deleted that directory from our sidebar. Now, one caveat here with removing directories is that this will only remove empty directories. If you want to remove a non-empty directory, then you'll have to use another module like the sh-util module in order to do that. Now, if we wanted to create subdirectories as well, then we would have to specify that we wanted to create all the non-existent parent directories along the way. So for example, if I wanted to create our temp directory plus another subdirectory, then let me go ahead and add that in here. Let's say that we wanted temp directory and this subdirectory here. Then I could say make dir, but if I run this now, then it won't work because temp directory doesn't exist. What I have to do here is I have to say parents is equal to true, and that will say go ahead and create any of the parents that you need along the way. So now if I save that and run it, then we can see that we have temp directory over here in the sidebar, and if I click on that, then we have subdirectory within there as well. Now, like I'd said before, you can't delete non-existent directories. So if you wanted to delete this temp directory, then you'd actually need to delete this subdirectory first and then the temp directory. Or what you could do is use the sh-util module, which allows you to delete non-existent directories. So now we've seen a little bit of how to work with directories, but we can also create files as well. So to do this, let me go ahead and create a new file here. I'll just call this tempfile.txt. In order to create this file path here, what I can do is just say path.touch. And when I run .touch on that object, if I run that, then we can see that now we have this tempfile.txt over there in our sidebar. And if that file had already existed before we ran that touch, then it wouldn't overwrite it. It would just update its modification time. Okay, so we can also rename a file or a directory using either the rename or the replace method. So if I wanted to rename this temp file to be lowercase, then what I could do is on this path object, I could do a .rename. And it's going to rename this path object here. And I will pass in, let's say that we just wanted this to be lowercase. So I'll do tempfile.txt. If I run that, and over here in the sidebar, we can see that this is now temp file all lowercase. Now, rename can actually be a little bit tricky. On some operating systems like Mac and Linux, it will overwrite existing files. On Windows, I believe that you'll get an error if the file already exists. I don't like to leave things like that up to chance. So what I usually do if I want to be careful is I can always use a conditional to check if the file already exists, like we did earlier in the video with that exist method. Now, if you wanted to be more explicit that the file should absolutely be overwritten, regardless if there's a file or directory already there, then you can use the replace method instead of rename. And that should work the same on any operating system. So I usually use replace instead of rename since I do those conditional existence checks myself. I don't like to rely on a method to do that for me. So if I wanted to use replace here, then all I would need to do, since this is named temp file lowercase now, let me change our existing path to be lowercase there. Let's say I wanted to replace this with temp underscore file. Instead of rename here, I can just say replace. And if I save that and run it, then we can say that replace works as well. Over here in the sidebar, we have temp underscore file.txt. And if you don't have any checks in place, then that will definitely replace that file or folder, no matter the operating system. So be careful with some of these commands because some of them will overwrite existing data. Okay, so lastly, if we wanted to remove a file, then we can use the unlink method. So if I wanted to delete this temp file.txt, again, let me replace our existing path object up here with what we renamed that to. So if I wanted to delete that temp file, then I could use unlink. So if I save that and run it, then we can see that that file was deleted from our sidebar here. So it is deleted from the file system. Okay, so we're just about finished up here. I still want to go over some scenarios where we wouldn't want to use Pathlib and instead use OS or another module like shutil. But first, I'd like to thank the sponsor of this video, and that's Extra Wallets. So I've actually been using an Extra Wallet as my daily wallet for about 8 months now, and I can tell you that I've really enjoyed this wallet as a replacement from what I had before. The one I specifically have is leather, but they come in a lot of different styles and materials. Their newest Pro model comes in 100% aluminum, and all of their wallets allow you to access your cards super easily just by pushing a button. One of the things I've found most useful is their Finder Card add-on, which is a super slim credit card size tracking device that's easily rechargeable, and one charge can last as long as 6 months. They have add-ons that also allow you to add Apple AirTags to their wallets, but I find the slim design of their tracking card much better since I don't even notice it in my wallet. I'll leave a link to their page in the description section below, and if you use code Schafer at checkout, then you'll unlock some extra savings on top of any current promotions that they're already running. I'd love it if you all could go show some love to our sponsors, and again, I'd like to thank Extra Wallets for sponsoring this video. Okay, so we've seen why we'd use Pathlib instead of the OS module and how it can be more readable and useful in a lot of different scenarios. But when should we still use the OS module or another module like the shutil module that we've mentioned a few times before? Well, there's a few scenarios. So like the name hints, Pathlib should be used for paths. So when you're actually doing things on the operating system like getting environment variables, the OS module is still what you'd want to use for things like that. And like I mentioned previously, Pathlib might not offer some more advanced features that you're looking for, like removing non-empty directories or copying files. So for that, you'd want to use something like the shutil module. I've not done a tutorial on the shutil module yet, but I do plan on putting together something on that in the near future so we can see what that's actually capable of. But for the most part, I've switched over to using Pathlib in all of my newer projects for working with file paths. And personally, I think that you should too, since a lot of the larger code bases have made that switch also. It might feel a bit strange once you first start using it, but once you get used to it, it definitely feels more intuitive and easier to work with than the OS module. So I definitely think that you should give it a try. But with that said, I think that's going to do it for this video. Hopefully now you have a pretty good understanding of the Pathlib module and why we'd want to start using this in our code. In some upcoming videos, I'm going to be getting back to some web development frameworks and releasing a new series on Flask and Django. So be sure you're subscribed to be notified about those. But if anyone has any questions about what we covered in this video, then feel free to ask in the comments section below, and I'll do my best to answer those. And if you enjoy these tutorials and would like to support them, then there are several ways you can do that. The easiest way is to simply like the video and give it a thumbs up. Also, it's a huge help to share these videos with anyone who you think would find them useful. And if you have the means, you can contribute through Patreon or YouTube, and there are links to those pages in the description section below. Be sure to subscribe for future videos, and thank you all for watching.